Good morning, everyone. In this video, I will be discussing on the microcontroller serial ports and interrupts related to the 8051 microcontroller. What the interrupts are there? What is an interrupt? What do you mean by serial communication? What is a communication? How the data would be transferred? So all the basics would be discussed. Then after this one, we'll be discussing on the um, topics of interrupts. First, we will start with the serial communication. Okay. First of all, communication is nothing but a signal to be transmitted, and when they say to establish a connection, you will be having a transmitter. We'll take it as transmitter as TX, and you would be having a receiver. So if you want to transmit a signal from here to here, there were numerous ways over here. Either you can go for parallelly communication, I mean to say all the bits are being sent parallelly in a packets, or you can go for serially. In serially, you will be having one bits. So how the serial communication is been established and how it runs over India 8051 microcontroller. So 8051 microcontroller accepts only serial communication. So, outside communication, when you go for you will be having a serial communication. So you mostly will discuss about the serial communication, how it established. So these are some of the basics of serial communication. So computer transfers the data in parallelly. I mean to say, if you are having 8-bit data, it would be requires 8 bytes. Serial communication, you need to transfer long wire over here. This is the example how the data would be transmitted over here. So when you go for serial communication, again it would be of two types: synchronous and asynchronous. So what do you mean by asynchronous? What do you mean by an asynchronous? How this would be applied over here? That would be the so in synchronous transfers at not at time. At a time asynchronous one byte would be transferred at one time and yeah, one time. Asynchronous it mostly 10 o'clock it would be transferred. So here, when you go for serial communication and serial communication, we will be having type of communication, universal asynchronous receiver and transmit. UART will be there. And next one, there will be another thing, USART, universal synchronous asynchronous receiver and transmitter. These are the two available modules there for serial communication. So in an asynchronous transmission, you will be having two major things. One is a start bit and a stop bit. So when you go for an asynchronous transmission, we will be having a start bit and stop bits. So what are these start bit, stop bit? So you would be having when your each character would be framed such a way that you would be having one start bit and stop bit. This is called as framing of data. So there would be block oriented data transfer. This. So these are some of the basics. I will make it fastly over here. So this would be the bit pattern which would be looking at. One stop bit would be there. One start bit would be there when you're sending the data. So this bit would be going first. Once you see this particular bit, there would be an agreement between the transmitter and receiver what would be the start bit and what would be the start bit. And usually the rate with which the data is transferred is represented at baud rate. This would be taken into consideration. Already, I think you are familiar with this one. So as you are from Tripoli, that's the reason I'm discussing on some of the things about communication. So baud rate is nothing but the rate at which a number of bits are transferred per second. Bits per second is given as baud rate. So here that would be the taken into consideration. Now coming to the 8051 serial port, you are having this is the topic which is there for you. So in your 8051, you would be having one synchronous and asynchronous serial port, and this would be controlled by SCON register, which is nothing but serial control register. They would be there. So in the data transfers, there would be two pins. One is an TXD, which is nothing but the transfer data, and receive data. These are the two pins where you can receive the bits and you can transmit the bits. So the serial communication is being established using these two pins. No separate requirement of an also there. Sometime clock through on this one. So there are the four modes of operation in your 8051 microcontroller. In mode 0, you would be having synchronous serial communication. And next one is 8-bit UART with time and data rate. And mode 2 is 9-bit UART with set data rate. And mode 3 is 9-bit UART with time and data rate. These are the different serial communications. So along with these SCON registers, you will be having SBuffer register and SCON register, PCON register. These three registers are special function registers which are used for serial communications. First of all, we'll go for SBUF register. It is an 8-bit register which is used for serial communication. It is not used for any other purpose, only for the SBUF. So for when a byte transferred via the TSI, it should be placed in the whatever the byte you want to transfer through the TXD line. It should be placed in what? SBUF. Then only the byte would be forwarded. We say it would be moved. So here, what I need to do, suppose I had a 1 byte of data. So this byte of data has to be placed in SBUF register. So when you are placing in this register, then each bit of this one, the transmitter TXD line and it will be transmitted. It will be transmitted serially. So here, whatever the byte you want to store, send it up, it should be stored over there. And when you are receiving a byte, this SBUF will be holding the 1 byte of data when you are receiving a data. Okay. So this is the use of SBUF register. This is a simple program. First you load into this one, copy into that one, and SCON register. So there is no specific bit pattern required for SBUF register. SBUF register, I mean to say, serial buffer register. We will say it as serial buffer register. Or we can say it as SBUF. SBUF register. So when you go for this one, it is just a buffer register where the data would be stored when it is receiving, where it is sending the data, it will be sent up. And SCON register, you will be having the modes of what are the modes you are going to set up your serial communication. Mode 0, mode 1, mode 2, or mode 3, that would be given over here. And that would be SM2. This is a pin which is SM2, which indicates enable multiprocessor communication mode will be enabled. And this is REN is used for enabling a data reception. So here, the 8, as I told you, 9, when you see in the mode 1, mode 2, and mode 3 is the 9-bit UART. When you are having 9-bit UART, this is a 9-bit stored. 9 would be stored in this one. When you are transmitting, it would be stored in TBA. When you are receiving, it would be stored in RBA. So these are the 9-bit locations for when you are using mode 2 and mode 3. Similarly, when you are going for start bit and stop bit, whatever the start bit is there, that is to be set when start bit is transmitted. Set when a character receive and transmit. This is the thing we'll be having in. So we doesn't go into the details about the modes of serial bits. Just we'll have a glance about this one. So these are the 4 modes of operations of serial program. So this would be the all the things. Anyhow, I will be sharing the videos. You can go through this one. For not required. This is we will be discussing on the interrupts. In any 8051, there are 5 types of interrupts are there. We'll be discussing. Interrupts and pooling are different. We'll say interrupt is nothing but it is an interruption given to a microprocessor to stop the mainline program and execute the interrupt submit. Polling is what microcontroller continuously monitors the status of the given device, whether it is asking for any help or it is asking for the microprocessor to perform any task. That is given by the polling. So here, interrupt and throughput are different over here, one to another. How these are different and how these should be there, that you can see it up. So it's been executed. First finishes the instruction which has been there when it has been addressed, and it also saves the current status of the interrupts initially in the stack. It jumps to the location into the memory called as interrupt vector table. Actually, each interrupt will have a separate a table called as interrupt vector table where the addresses of the interrupts called are being stored. It will go to that address and it will be running that interrupt subroutine. Microcontroller address the ISR is nothing but interrupt subroutine address would be from inverter and jump circuit. Starts execute the interrupt subroutine until it reaches the last instruction return. So here this would be the how the flow would be there. The inline program is been running up smoothly for the without any interrupt in the first example. Now the second example is that the inline program has left over here. Immediately it is called for the um, interrupt subroutine. It will execute the interrupt subroutine. After interrupt subroutine, when it receives the return, here you will be having the return. Once it receives the return, it will come back to the main system. Here, usually interrupt subroutine would be I some interrupt would be given over here. So RST or some value has given. So according to that interrupt, it will go there and it will come back, and again it will go back, come back. So here, whatever the program has been left out over here, the next instruction immediately after the call or the interrupt, it will come back again into this one. This is about the interrupts. So usually there are six types of interrupts in your 8051 microcontroller. One is an um, reset, power reset interrupt, and one is then a serial communication. Two interrupts are for timers, two interrupts for external hardware. So the flow, I mean to say causing an interrupts would be these are the six. Okay, these are the six types of interrupts you will be having: timer 0 and timer 1, time counter 0. So at the starting, only five interrupts were introduced. One is an external interrupts, two timer interrupts, one serial communication interrupt. So you would be having timer control, SCON, and enabling and disabling of interrupts. How you can enable the interrupt enable register. These are the six interrupts you will be having. Over here, EA is the master of this one. Enable all the interrupts. And X indicates external. Remember this point. X indicates enable external 0 interrupt, enable external 1 interrupt. T indicates timer. Enable timer 0 interrupt, enable T1 is nothing but enable timer 0 interrupt, and EF is nothing but serial communication interrupt. So any bit is there, interrupt should be accordingly set and reset. So you can enable or disable the interrupts by providing the interrupt enable register, special function register. Directly you can move that accordingly. The interrupts would be enabled or disabled. So how to enable and interrupt disable? We'll see in the tutorial. One example will be shown. Here you can do this one. And this is the interrupt priority register. According to this one, all the interrupts are given. Whichever the high is been given one, that is given the highest priority accordingly. External. So thank you everyone for watching this video. I hope you have understood the concepts of serial communication and interrupts. And if any doubts are there, anything is there, we'll discuss in the tutorial. Thank you.